Hey all, it's me. I come to you tonight very briefly to talk to you about box and whisker plots and variance within statistics. So I'm going to start by sharing my screen with you, and I'm going to pull up some data that I have previously manipulated and also run graphs on and just kind of speak to you about what I did. So we were given a data set for the 17-18 school year and the 18-19 school year for reading for grades 3 through 8. And it was for a district, so there were a large amount of students. And as you can see, the original data set had student ID and their Texas unique ID numbers, district ID numbers, and then what grades they were enrolled in 17-18, gender, ethnicity, and then their raw scores. And of course, in fourth grade, students take the reading test one time. And in fifth grade, this particular year, students had 3 administrations of the reading test. So there were many other columns of data. So what I did was basically weed out down to the absolute bottom of what I needed. There was a 17-18 sheet, an 18-19 sheet. I combined the data to make a 17 through 19 sheet, and then took out most of the things such as student birthdays and other identifying information that wasn't necessary to what I was doing. Theoretically, I could have taken out student IDs and all of these identifiers and just left some basic identifier and just worked with that. But it's good to get in the habit of leaving various ways of identifying members of a data set, especially when we move towards our dissertation and we're working with larger data sets. So that said, I cleaned up, and then I combined spreadsheets. And so you can look at data side by side from 17-18 to 18-19, and you'll see grades 4 and 5. And then, excuse me, here was raw scores. You can see for admins 1, 2, and 3. These were initially listed in a series like this one where my arrow is, would have been 8, 17, 21. And what I did was just add in additional rows and separate the text so you could see for each of the admins. And theoretically, I should have gone in and labeled them admin 1, 2, and 3, but for time purposes, I just left it as is. And then I grouped the 17-18 raw scores together so they would be easier to work with. These box and whisker point plots charts are my favorite. I like the way they're represented, and when you change the color on them, I just like how easy they are to interpret and how they are to look side by side. And I was having fun playing with them, so I even went a step further. So I took my data and inserted a graph and did the box and whisker plot. And you can see I relabeled these. These were for fourth grade scores. The raw scores for reading for 17-18. And this would be called an upper bound, and this would be a lower bound, which simply means the lowest the student scored to the highest the student scored. And then right here in the middle is your median score. So you can see where the average was. I'm going to come down here for just a minute. And then I also pulled the 17-18 and the 18-19 together and ran the charts and color coded them so you could actually see the various quadrants and variance and how students rated from one to the other. So there is that. And then this was kind of cool. I took the data from all 3 attempts in 18-19 and rated them. Important to note that the data set gets smaller and smaller because theoretically with each administration, administration 2 and administration 3, you're having a lesser number of students take the test. These little cool dots right here are some outliers, and those are students that performed well outside the given range or variance. Let's see. So then something you could do is take and run your descriptive statistics. So you go into data analysis, descriptive statistics after you've highlighted whichever years you want to look at. So for this particular, or you can run them from a graph even, but for this particular chart, I'm looking at raw scores 17-18 versus raw scores 18-19. And you can look at the mean went from 21.1 in 17-18 to 22.6 in 18-19. So that shows some considerable growth. Of course, you have to take a little bit of variance into the factor that in 5th grade, they did get to take the test up to 3 times. But for the most part, most students only took it 1 time. So the one administration as a 4th grader compared to the one administration as a 5th grader shows some pretty significant growth. You can see the standard error, and then you can look at the median. And if you look simply at the median score, at the 21 to 26 difference, that shows quite a bit of difference. Standard deviation, as we'd mentioned earlier, when you compared, I'm going to come down here to the 18-19, there's a larger variance in scores as shown by upper bounds. So if we look at that standard deviation, it went from 7.9 to 10.8. You can look at the difference in the variance. You can look at the range, minimum and maximum. And then you can look at the count of students that took the test. And there's just various statistics you can run with these. Like I said, I like this type of chart the best because to me, it allows you to do the most with an easily visible data set. So, of course, descriptive statistics, data analysis, you can use the tool pack or just the AbleBits tool pack, or you can use just the regular Excel, which is what I used. It gives you a summary of your output range, your summary stats. You can change labels. This is kind of cool, like all charts in Excel, you can go through and you can look at plots and you can show inner plot points and outliers and the mean markers. And there's just a number of things you can do. You can also change your color and you can relabel your axes. So you can make these charts as complicated as you want. And then you can come here like always and you can add elements to the chart. You can change your styles like anything else. You can go through here and expand your chart sizes to make them bigger or smaller to fit your purpose. And in a nutshell, that is basically box whiskers and variance. Thank you for joining me. I'm going to stop sharing and end the presentation. Good night.